Hello and welcome to Innovize's Utility Innovations webinar series. And thanks for joining us for the City of Denton's proactive approach to asset management featuring InfoMaster and Cityworks. Very pleased to have today P.S. Aurora and Tyler Dawson from the City of Denton, as well as Brent Wilson from Azteca Cityworks. And my name is Rajan Ray. I'm the Director of Marketing with Innovize, and we're going to be talking a bit about asset management, asset prioritization, and the related technologies behind those two. And so this webinar is going to be broken down into three sections. The first section, both Brent and I will discuss the technology and some of the companies behind these asset management case study that City of Denton is going to be presenting on, followed by the actual case study by Tyler and PS, and then ending with a question and answer portion. To ask questions, your microphones are muted, so the only way to ask questions is through the chat screen, which is towards the right. There's an ability to send to all panelists, and that'll assure that all of us will receive these questions so we could respond to them at the tail end during the Q&A session. So I'm going to get right into it, talk very quickly about Innovize. This is our 20th anniversary, so we started with hydraulic modeling software that was integrated with GIS, and we expanded to do much more advanced applications, including real-time monitoring and management, as well as asset management, which we'll be talking about today. We are gold business partners with Esri, and the integration we have with their platform is very tight and seamless, so you could access their native data layers, and we received an award based off that type of integration last year at their partner conference. And that's one of the highlights I wanted to just kind of go over with InfoMaster. It's 100% GIS integrated, specifically built for water, sewer, and stormwater systems. You're able to bring in CCTV data through our wizards and have that automatically geocoded within the GIS platform and shown in this 3D view, which PS and Tyler will show in a little more detail during their presentation. And then we have a bunch of analytical tools and algorithms behind the InfoMaster tool, including risk-based prioritization, rehab planning, and deterioration modeling. So starting off with risk-based prioritization, quickly go over some of the concepts and what it looks like within InfoMaster. But you have your likelihood of failure and your consequence of failure, so you could take from your different data layers, from your GIS to CMMS like Cityworks, as well as your hydraulic model results. So maybe on the sewer side, you want to look at capacity. On the water side, you're looking at velocities or fire flows or water quality, and have that incorporated within your risk analysis. So when you combine the two, likelihood of failure, consequence of failure, basically all of your assets fall into a specific category or risk class, and you're able to do more in terms of just visualizing that in a very user-friendly manner. Just by clicking on any asset, you could actually look at what the risk score is and what made up that risk score. You could view pie charts and different graphs associated with it, but actually look on a tabular view and just assess and kind of identify where they're located within your system. And very easily, you could kind of see how your system is broken down in terms of risk. But beyond risk, you also have the ability to do rehab actions and financial planning and budgeting. So that includes our decision tree, where you could look at every single one of your assets. Will walk through a specific decision tree that you configure. Again, PS and Tyler will show you, they've taken this to a whole nother level, and but they'll show you during their case study. But basically, all these little orange blocks are the actions that your asset could go through. It could be replacement, relining, point repair. It could also be an O&M task. It could be further CCTV inspection. It could be smoke testing, dye testing, et cetera. But ultimately, at the end, you have the ability to pull up, again, any asset within your system and see not only the risk score, CCTV score, but also the rehab action and the reason behind that action, as well as the cost for that action. You could also generate work orders and bring that into your CMMS, which now you have the cost for each of these different types of conditions. You can break them into projects or phasing for short-term as well as long-term financials. You also have the ability to take data from your pipe cohorts or groupings, materials and age, for example, or as well as previous break data, and extrapolate that to look at failure probability or survival probability, and associate that with your rehab and replacement decisions. This data can also be used as a baseline replacement cost calculator. On the water side, we have some additional types of network algorithms to look at your valve and pipe criticality outside of the hydraulic model. So you actually could look at specific assets within your within InfoMaster and kind of assess if that was taken out of service, if there's a pipe break or a failure, how many customers will be affected. You can actually sum up the usage value if you have the customers within your GIS, as well as how many isolation valves you need to close. So really kind of helping you assess the criticality, how critical these specific assets are, and then tying that back into your rehab planning. And then lastly, before I hand it off to Brent, we have a very tight integration with Cityworks where we could consume any new data that comes in from the field from Cityworks, as well as generate work orders that goes back into Cityworks. So for inspections or other types of work orders, you could do that seamlessly within InfoMaster and both Cityworks. Everything is integrated with GIS, and you could bring in CCTV data as well as hydraulic model data from any hydraulic model, and then generate configurable reports as well as bring it back out to your web maps or ArcGIS Online and other avenues. So very flexible in that standpoint. So with that, I'm going to pass the controls back to Brent, and he'll talk a little bit more on the Cityworks angle.
Thanks, Rajan. Let me get this set up real quick.
Sounds good.
Okay. So just a little bit about Cityworks before we get the city of Denton up to share their story with you. My name is Brent Wilson. I'm over the sales and marketing department at Cityworks, and there's my information if it's something that you'd like to contact me. As far as Cityworks goes, we've been in business over 20 years. We're a privately held company out of Utah. We are a platinum partner of Esri. We sit in their partner council with them as well. We have offices throughout the country, but the bulk of our offices are in Sandy, Utah. We have over 600 licensed organizations throughout the country and throughout the rest of the world: Sweden, Australia, the Middle East. I think we have a new client in South Africa as well. So we have some other clients out in other parts of the world, as well as the bulk is here in North America, United States, and Canada. Over 30,000 end users and 50 partners like InnoVise, where our applications work together. So hopefully you'll see some really interesting things today from that. We do provide software. We're a software company. That is what we do. We provide asset management, work management applications. We serve different markets, from local governments, utilities, airports, and other things as well. And so the software that you'll see as far as Cityworks goes today, it is a work management system that can really manage any asset, not just water and wastewater, but that's what we're focused on right now. One thing that is pretty interesting about the way Cityworks works is that we're a GIS-centric application, and we leverage your spatial data, your asset inventories, and all the data that you're putting into your GIS, in your Esri GIS. We're going to leverage that data to make it something that you would be able to utilize within your asset management, work management system. It's the same way that InnoVise does their risk analysis and stuff. They're using the GIS. And so because of that, we're both of our companies are leveraging the power of the Esri platform to be able to have a single asset repository doing different things within your organization. So, you know, your Esri software is going to act as your authoritative database and your system of record, and we're going to leverage that within Cityworks. This gives you a way of being able to plug in all your systems of engagement, you know, whether it be, you know, phone apps or web apps or, you know, tablets or whatever you're looking for. There's just different applications that you're going to want to plug in to get all of your people engaged in the process. So, you know, this isn't really just meant for the back office people. This is actually meant for the people out that are fixing the pipes and you know, exercising the valves and flushing the fire hydrants and those types of things. This is meant to be in their hands so that it's then feeding that authoritative data back to, you know, to the system so that everybody can take advantage of that. Along with the GIS-centric, you know, ability of Cityworks, we're also a platform. Just like Esri, we open up applications with, you know, open up APIs within our application for other systems to be able to do things with that. So just as we sit on top of Esri's platform, other applications can sit within our platform as well using APIs. And you know, this is one of the ways that InfoVise and us work together through our APIs within our respective companies. So that way you can have, you know, within our application, you can have any device, anytime, anywhere, whether it be a phone, a tablet, or you know, a laptop or a full office computer. But at the same time, you can also have your financial systems coming in, your 311 systems coming in, or, you know, in this case, risk analysis data coming in and being pulled out as well. And so with, you know, with our partner network and our implementation strategic partners, you know, you can have everything from, you know, like in this case, automated vehicle location, but then also the modeling and the risk analysis, which is what we're going to be talking about today. There's just a number of different partners that we have out there that do different things that write great products like InfoVise, and that's why we team up with these folks to do things like what you're seeing today. So overall, the public asset management system that Cityworks provides, we're focusing on the asset management piece today, but we also do your planning and your permitting and code enforcement, business licenses and inspections. So we can handle the community development side, which really feeds your asset management folks the data that they need over time into their work management. And so we kind of handle the all-encompassing life of that asset from a work management standpoint in a process. And then, you know, of course, whenever you have reported problems, you've assessed those problems, you repaired those problems within our system, then you could do some analysis and then more life cycle type of analysis when you get into InfoVise, being able to show, hey, where do we need to plan the follow-up work and those types of things. So, you know, this whole environment that you're talking about is really not only to react and prevent, but also to decide on what you're going to do in the future. So with that, I'm going to turn it back over to Rajan, and we'll get to hear more from the City of Denton.
Thanks, Brent. So I just want to do some quick introductions to PS and Tyler. So PS Aurora is Assistant Director over Wastewater Utility for the City of Denton. The implementation of their asset management program in Denton using InfoWorks and Cityworks has won awards for 2014, 15, and 16 from the Water Environment Association of Texas. So it's a real treat to have them presenting on this, their specific study here. In 2016, PS Aurora won the Sidney Allison Award for significant contributions for engineering operations, maintenance, and wastewater collection. Tyler Dawson is the wastewater utility coordinator for the city. He took on a key role of the implementation of the Cityworks server and InfoMaster Sewer, and continually works to improve and refine these use of these applications. He has a bachelor's in business administration with a concentration in decision science from the University of North Texas. With that, PS, take it away. Thanks.
Good. Thank you, Raj. The folks, we wanted to give you all as much information concisely as we can about the Denton Asset Management Program, So we have a lot of slides to go through to bring all that information in. So I'm going to dig right in, and we will keep at a pace. Hopefully, you can stay with it. So let's look at the scope, why we want to do asset management. So we'll touch on that briefly. What software tools we use in Denton to put that asset management program together. We will look at those. We will go a little bit of detail on how we are doing the asset management in city. And then we will show you the benefits that are accruing from it. A little bit about Denton. It's about 125,000 population. It's part of the Dallas-Fort Worth Metroplex. If you see on your screen, here is 35. That splits into 35W that goes to Fort Worth, and 35E goes to Dallas. So we sit at the top of the triangle. About 522 miles of main line, rough replacement costs $425 million. Sewer system history a little bit. Denton is pretty old. We have sewer lines dating back to the 1910s around the courthouse square. The first Interceptor was built serving the downtown area in 1925. 27 lift stations, 2 plants, and you add the private lateral in about 783 miles of sewer line in the city. How the city is divided, it is the Cooper Creek Interceptor right here. It has a pump station that pumps into the Pecan Interceptor. That goes to the wastewater treatment plant right here. And the Hickory Creek Interceptor, it has a pump station that pumps into this State School Interceptor, goes to the major plant that we have, the Pecan Creek Water Reclamation Plant. And then we have another plant here serving a 50-plus community. That's the Robeson Ranch here. So why we want to do asset management? Just like us, and we are a mid-sized city. Some of you are probably pretty large. Everybody has a lot of investment in the collection system assets. Just like us, I'm sure you have limited dollars for O&M and replacement. If you are in the wastewater business, we want to be, good steward of the environment. We want to reduce the SSOs. We want to reduce our environmental footprint, so we don't have overflows going out to creeks, etc. We want to work smarter, and we will show you how we are working smarter, how we are getting high employee morale, and lower rates, how we got to lower rates. We will show you how we got there using the asset management program. And this may be an oxymoron, but happy ratepayers, nobody likes to pay money, but we feel that we are providing a great service by reducing the expenditure. So how did we implement the asset management program? We started out with the S3, which is the big daddy right there. Everybody operates in that environment, as they mentioned to you earlier. We started with Pipeworks, which is now Cityworks. We started out with HydroWorks for capacity management, which is now InfoWorks. We did initially implement the WRF scraps model for prioritizing our collection system. Then we implemented CapPlan, which is now InfoMaster. From the get-go, all of these software, when it was implemented, we had operations staff sit on the table from the very beginning, do all the beta testing, and get satisfied that, yes, things look right, and we can buy into that. And all of that data, you got to manage it right. So, we added one IT database professional, which is Tyler, and then all of that leads into the CMOM program. And how we manage our CMOM program, we will show you that. So it's a step-by-step because we did this over a period of time. 90s, we had the S3 GIS, 98 Pipeworks, and then 2012, we went to Cityworks with that server. Every thing that our collection department does gets recorded into the Cityworks. So over time, it has become a great source of historical data on the sewer system maintenance and repair for us. So let's look at how we use the Cityworks in Denton towards the asset management program. As I mentioned earlier, work orders for everything that you see here: flushing, CCTV, point repairs, service line replacements, main line replacements, We get calls from customers, order complaints which have gone down tremendously, chokes and overflows which have gone down tremendously. And we just started doing manhole inspection as part of the work order through the Cityworks. So I like to say that our guys in the collection system, when they are on the city time, even if they breathe, it goes into the work order in the Cityworks. So every activity goes in there. With that, I'm going to turn this over to Tyler to go through some of the details.
All right, this is Tyler. We're going to look at an example of how we use Cityworks. What you're seeing here is a snapshot of our Cityworks environment. We're in Cityworks 2015. And on the right side, you see a map that represents our basin cleaning process or flushing process. You'll see two colors here. There's a blue and a green. The blue is going to be our 5-year cycle, and the green is our 10-year. We also have a 1-year cycle. PS will tell you a little bit later of how we developed that system to how we clean our system in a 1, 5, and 10-year cycle. But we're going to zoom into our 5-year cycle here, just a portion of that map. And you'll see that there are two colors. There's a dark blue and there's a light blue. The dark blue actually represents our done lines that we've cleaned during the current cycle, and we have a database routine that checks those every night based on the work orders that are entered. So what happens is a flushing truck operator will come in the morning and he'll look through the dark lines and see what's been done, and where that stops and turns light, that's where he's going to start working that day. So that automated system helps him know where to go next. So we're going to make a work order on that line, and the most critical piece of this work order is that it is tied to that line. This is our asset going from manhole to manhole. We have an asset ID here. We always enter our work orders against an asset wherever it applies, because that way you know exactly what work's being done on an asset. If you only tie it to maybe a geographic area, you don't get that asset management data, and it's a lot harder to make those decisions. So we make a work order against that asset and fill in some details, description of what we did. This is a basin cleaning work order. Who did the work, when the work was done. We even get some detailed information like some comments, attachments, which can be pictures of the manholes or the pipes that they're working on. And we enter in cost data. So you'll see here that we have 1.5 hours entered for 2 employees and 1 truck. All of those, every employee, every truck has an hourly rate that we cost, and it comes up with the total cost for that work order. And then materials or parts as well. So if we use a gallon of degreaser, we'll cost that at the appropriate cost. And all that comes together. You got your cost of maintenance. You got all kinds of details on the work order. And that data is extremely important. You've all heard the term garbage in, garbage out. Well, we don't want garbage data here. We want some good, clean data that we can dump into a system to analyze it and spit out an answer. So our quality control process starts when the field worker sends that work order through a supervisor and then through a department admin, and both of those people check that for quality standards to make sure it's up to snuff. We also, since that's such a big job, we've kind of decided that if a person looked at every work order, we would probably need a part-time employee or more just to do this job. So we actually made a database routine that helps us with that. It looks at a selection of work orders as they're done, and if it meets our quality standards that we've programmed into it, it'll go ahead and close that work order automatically. And then if it doesn't, we stick this instruction in there to tell our staff why it didn't close. It'll help them streamline their process to review it. So all of that's done to make sure all these many, many work orders that go into Cityworks have a good enough quality that we can use them later, and that'll really bolster our asset management program. I'm going to hand back to PS.
Thanks, Tyler. So let's start looking at the further asset management program. Capacity, improvement is necessary. If you don't, wet weather is going to be a real bear. You're going to have overflows. So that's the first thing we started out. And in '98, we were implementing impact fees in Denton, and we purchased the HydroWorks model at that time. And now it's InfoWorks, so we went to that in 2005. We have a senior engineer in-house that does the modeling. So through the model, then we look 20 years out, and then based on the need, we will have a 5-year plan for sewer lines, and then we have a 10-year plan by state law that we need for the impact fees. And we look at the 20-year horizon, so all the CIP for capacity comes through the InfoWorks model. Other thing that it does for us is the new development. If it is a sizable development, and Denton has a lot of area that's going to develop, it will be the 3rd largest city in the Metroplex over time. So we have lots of raw land out there in our ETJ. Anytime a large development comes in, we have to make sure that we can accommodate that. So the tool I have is InfoWorks. I can go to my modeler and say, okay, Jim, let's look at the current flow in that line. What is the capacity of that line? So what is the remaining capacity? So immediately we have the answer, can we accommodate that flow or not? It's a great tool for that. Here's a snapshot of what the InfoWorks looks like. If you have this model, you will relate to it. And then moving on, this shows you the 5-year CIP. It goes by year, and you can see for each year what work we are doing. So this is how we do our budgets and for each year, and we look at 5-year budgets going forward. This is a benefit we got from the InfoWorks model. You can see this is 2001, roughly about 36 inches of rainfall. This is showing the rainfall. Here is the amount of overflow, 46 million gallons. We were under an administrative order, believe me, bad at that time with EPA. And we implemented the model back in '98. We started to do the projects. And we were also, at that time, upsizing our plant. And we looked at the model, and it showed that we will be getting about 53 MGD flow coming to us during wet weather conditions. And initially, the consultant was looking at in the 30s as a peak flow going through the plant. So we went to the consultant and asked them, hey, look at the 2-hour peak, see what is the maximum we can process through the plant, including by adding some hydraulic capacity. Keep the process as it is, but add some hydraulic capacity through pipes. So they came back to us with 46 MGD we can push through the plant. So we put a 46 MGD design. We put a UV system that was the largest in Texas at that time at 46 MGD. And you can see with the collection system upgrade going on and the plant being able to push that much flow through. And at that time, we went ahead and also designed a 7 MGD storage basin at the plant that was also modeled through InfoWorks. And this is a 51 inches of rainfall we got in 2004. We had more than 8 inches of rainfall in 1 year, and in 2004, that was getting close to the 100-year storm here. 100 streets in the city were closed at that time. This is just a blip, as you can see right here. And we are chugging along real nice. Last year, 37,000 gallons of overflow. Majority of that was on the Pecan Creek Interceptor, which is currently undergoing construction right now. So we will hopefully reduce this substantially. Last year, we got 55 inches of rainfall, which was a record in the Dallas area. So we are really proud that we reduced the overflow amount by 99.92%. Moving forward, so you can see that we had a great handle on the wet weather. But the issue is the existing condition of the existing system that you've got. Let me show you this one more time. Right here you see the rainfall, 2005 and 2006. The good Lord, when they give us the big rainfall, they remind us they are still there. So as humans, we have to remember that. We got 18 inches of rainfall after that, and another 20-some inches, pretty dry years here. Our normal rainfall is 35 inches. We consider that to be a normal year. So we were getting a lot of overflows during this time, real small ones, because there was not much rainfall, so it was not the wet weather. It was the dry conditions, but 10 gallons here, 20 gallons there, 100 gallons there. And I was telling our collection system manager, what's going on? Why I'm getting all this overflow reporting to be done here? And this is a quandary. Why it is a quandary? You have a lot of old clay pipes that choke on you. You have frog, you have fats, roots, oil, and grease that get into the lines, and they are not getting flushed with the wet weather. So during dry weather, it is, caulking, basically choking the line, and it is causing overflow on you. Small amounts, but it's a number you have to report. In Texas, 1 gallon overflow, you have to report it to TCEQ, Texas Commission on Environmental Quality. I like to say sewer lines don't tell us what's wrong with them. They are introverts. They are not extroverts like the water lines. Water lines, when they leak, Everybody can tell water running down the street. Sewer line doesn't tell you that. So investigating the potential CIP becomes a real bottleneck. Where do you spend the dollars? Which lines should you fix? We all have limited resources in manpower. It takes a lot of time evaluating and discussing, and it takes experienced personnel. So we looked at, okay, we got lots of data in Cityworks, and it's all digital data. How do we leverage it? And I went through EPA documents. We looked at ESCE, 10 state standards, whatever I could find. I could not find an overarching program that would give me a full asset management for the existing collection system for rehab. So we looked for a priority model, and we are a contributing member of WRF. So we found the scraps model in the WRF database. So we implemented WRF model at that time, back in 2008. So it allowed then Denton to focus inspection programs in areas most likely to need attention. Scraps, what it does the evaluation of each pipe by probability of failure and consequence of failure, and it gives us a number from 0 to 100 for each pipe. And through that, then we can look at the numbering system is, if you higher the number, higher the priority. So we use that to give a priority to all of our lines in the system. I want to mention that the WRF model is not updated, but InfoMaster is. So currently we are moving towards implementing the priority ranking through the tool within the InfoMaster, and we will transition away from scraps. So using the probability and consequence of failure, you get the ranking from 0 to 100. And how did we use that? This is the scraps output. You can see the need to inspect scores right here. This is the probability and consequence of failure, and it gives you other data also, but this is the number to look at. How did we use that data? It gives us a digital warehouse. I want to mention to you that for each line segment, we had to put in almost 86 data points to populate the database in scraps model. So we had a lot of gap in our knowledge because nobody has 86 points of data on each line. And we jumped in with both feet, and we put years and years worth of work, and we continue to do that to make our data more robust. And that's one of the benefits of moving in this direction towards asset management. So now we have what is the size of pipe? We have a percentage by pipe size. We know what is the percentage of each pipe material. Just to flag you here, when we started out with scraps, we were looking at about 47% VCP. We made assumptions that in 84, anything that was 84 and over was PVC, and prior to that was clay tile, unless we knew it was not clay tile. And we were about 47% on clay tile. Over time, with pulling data from the field, we have gone to 71% PVC. We know by year now what line is how old, so that really gives you a big input into what line you should be working on. As you can see, by color coding, we know what year the line was constructed. Using that scraps data from 0 to 100, we said anything that was 85 and over was high priority. And lo and behold, all the old part of the system fell into that. The newer parts fell into under 85, and that was beautiful. So we said, okay, these are the lines give us more trouble. We go 5-year. We want to make sure those lines are taken care of, and these are the 10-year lines. Then what happens is when you have a buy-in from our operations staff, they said, hey, they came to me, P.S., look, we have these lines that we have to go, which are close to restaurants and apartments, and where we have to go and flush these lines a lot more. So they came up with a 1 year. So that's where the 1, 5, and 10-year cycle we have, that we go out and flush these lines. So we got this InfoMaster scraps model working very well. We started to use some of the priority ranking in decision-making for which lines we should be rehabbing. But it is not a full asset management program. Our staff had a buy-in. They understood how these models work, so they had a great comfort level. Time was to move on to a full asset management program. So we initially moved to CapPlan. That is a predecessor to the InfoMaster model. It is a complete decision support asset management program. It integrates everything, the GIS information, the CCTV video, because you put that data in, it will compute the PSCP ranking for you. And we do use PSCP. We have trained people in that. It will take the hydraulic modeling data and see which lines are stressed during the wet weather condition. And it will also prioritize your system for you. So what does CapPlan do? It looks at individual repairs. It looks at repairs, both major and minor, full replacement costs, because we take our bid data or our in-house construction data and we populate the database. So it comes out as a replacement cost. It tells you what rehab method you should be using. And then it also gives us a priority ranking. We can go for CCTV. And beauty of it is it does that for every pipe. With that, I'm going to turn this over to Tyler.
Thanks, PS. So when we developed CapPlan, of course, Innovise introduced a new product, which was InfoMaster, and it was really a replacement to CapPlan. It kept all that functionality, and the transition was really near seamless. We put about two years' work into building CapPlan to what it was, and we were able to do a pretty quick transition into InfoMaster. Of course, with the new software, you get improved processes. So someone like me who runs the model got to go from a tool that maybe took 10 to 20 minutes to run, and all of a sudden that's down to about 1 or 2 minutes, maybe a few less button clicks. And InfoMaster added some geographic and graphical outputs. You saw a couple of those when Raj was introducing the presentation. And that may not seem like a big deal at first glance, but if you think about outputs that come into spreadsheets and maybe detailed maps, they make sense to somebody like me who works with spreadsheets and works with detailed maps. But PS keeps bringing up the fact that we bring our operations staff into this. What they're used to is seeing a pipe in the field. So a lot of these outputs relate to a pipe in the field, and it brings them into the picture and helps bring out their experience. And of course, they introduce some integrations to CMMS systems like Cityworks, which we're talking about today, and some CCTV systems that streamlines their processes. I'm going to walk through an example here. Of course, we said InfoMaster reviews every pipe. We're just going to look at one at a time here. And this is just a typical pipe in our system. You see the green line as it's shown in GIS. And then you see this facility internal view, which is a graphical representation of that pipe. You get a few details with that, like you get your downstream manhole, your upstream manhole. You can see the length of the pipe here, about 313 feet. And an inspection, which we did on August 25th, 2015, and it covered about this length of the pipe. So we're going to start looking through that CCTV data, and InfoMaster is going to start interpreting that for us. Of course, we do PACP-rated inspections here, and InfoMaster looks at all of those PACP-coded observations. First thing it sees are the taps, all the connections. It's actually going to geocode those to the correct side of the pipe when you look at it in GIS, and it's going to draw them on the correct clock position on the pipe drawing here. And you have the codes here that tell you what type of connection that is and what condition it's in. Next, it's going to look at your point observations and point defects. It could be problem defects like a fracture or a crack. It could just be an observation that you reached the manhole or you saw high water level. And again, those are drawn out to the correct clock position. You can see a little more detail here of how some of those defects cover a certain portion of the pipe, and it draws it out here to make that a little easier to understand. And then we have our continuous defects, which cover a particular length of pipe. It draws those to the correct length and to the correct clock position, and you get all the detail that comes with those observations over here to the right. So at this point, InfoMaster knows what your CCTV crew found, and it's going to start trying to figure out what to do with that pipe. The first step is what it calls a draft plan. This is only considering the CCTV data, but here it recommended 8 point repairs. We can see some of these repair an individual point defect, some a longer continuous defect, and some merged multiple defects together into one long point repair. Now, this isn't the final answer. We want to know what to do with the full pipe all the way from manhole to manhole. And so that's where the next step comes in. It's going to recommend a rehabilitation method. And because of the total condition of this pipe and everything we know about it, it recommends replacement here. It'll cost out 313 feet worth of pipe replacement. Also costs out lateral replacement for the taps that we saw in the first step of this example. And the way it does this is through the flow chart. This is really, to me, the core of InfoMaster's functionality. This is what we spend most of our time on. This flow chart here is what actually comes with InfoMaster when you buy the program. This is exactly how you see it when you first open it up. It's going to run every pipe through this from the start and through each of these blue nodes. Like Raj mentioned, this will go through all the criteria, push it down the flow chart until it gets to one of these kind of red-orange nodes, and that's going to recommend a method to rehabilitate that pipe. Could be at most replacement. You see another replacement here. Could be a defect repair, port repair, that again with full lining. You could slate that for a CCTV inspection, or you could decide that's no action, that you don't need to touch that pipe for a while. So what we did here, we spent a lot of time customizing this flow chart to Denton's needs. We're looking at a simplified view just so we can see it here on one screen. I'll walk you through some of the steps that we included in our flow chart. The first step is for a planned rehabilitation method. If you've already planned a rehab on that pipe, let's not reinvent the wheel. Let's keep that on the plan. Next, we look at, have we done a successful point repair? That would be a point repair with no subsequent failures. We might decide that we can leave that pipe alone for a while. Both of these are actually data that's housed in Cityworks. So while the example is looking mostly at how the CCTV data is interpreted, this is where Cityworks comes into play. All of our planned rehabs are work orders that are just pending completion. And then our point repairs are recorded every time we point repair a pipe. And then the chokes that would constitute a failure are recorded in Cityworks. So all that comes over and helps this flow chart run through all the correct data. Next, we look at, do we have CCTV on file? And you've just seen how InfoMaster evaluates that data and recommends a repair or possibly a no action based on that. And next, we have QuickCam. Now, QuickCam is our flushing truck nozzle-mounted video camera. We run that through a pipe after we clean it, and that can be checked in the field so the field worker can see exactly what was in the pipe that he just cleaned. And we also send that back to the office for a detailed review of that video. Once we can see that, once we're seeing the inside of the pipe, we can make a very educated decision on what to do next, even without having a full PACP coded inspection on file. And then what's left, these are the pipes that we don't know much about. We haven't opened them up. We haven't sent a camera down them. So we're going to start prioritizing those for inspection. First category here, we call this our performance category. We've had performance issues with these pipes because they've choked in the past. And we separate that into 5 categories based on the number of chokes, material, diameter, and age of the pipe. And then finally, we haven't seen these pipes. We don't have any performance issues with them. These are our risk pipes. So once again, we pull in the scraps, risk scores, the prioritization scores, and over 80, we separate that into a couple of different categories for scrap scores over 80, and we go investigate those as well. This could be probably pipes that are in an older part of town. They might run under a highway or near a creek. And a lot of these pipes we rule out as no action. We say we don't need to touch these for a while because we've evaluated all the data and we don't have concerns about that pipe. This is my favorite category because it actually pulls it off of the action plan. We don't have to do anything for some time with these pipes. And again, this is a simplified view. So here's the full view of our flow chart. And like I said, we put most of our efforts here. This is where we bring everybody to the table. This is where we bring in the operations staff and really program our logic into this. This has always been a living document, and we make sure to keep it that way so that when anything changes, when we learn something new or when we discover some piece of knowledge that we didn't have before, we can always put it in here and make this a continually improving process. I'll pass back to PS.
Thanks, Tyler. I did want to point out that the priority ranking we have, the program is very flexible, InfoMaster that way, because the output from the scraps model, which was priority ranking, goes as an input into the InfoMaster, which we will transition over to InfoMaster as we go forward. So let's look at the InfoMaster results, what it does for us. And what you see here is a dream come true for a collection system manager and the wastewater department. What we now have is a plan for every pipe in the system. You can see in color coding, if there's a planned CIP, it's in red color. If it is a planned recommend replace decision, you can see that color. And so on down, you can see the point repair to investigate, potential CIP review. We have different rankings for CCTV. And if it is a P1, it's a high ranking and so on down. This is based on the chokes, and this is based on the scrap scores. So what you have right now, either there is nothing to do or there is something to do, but we know what we have to do on every pipe in the system. So how do we use now the Cityworks and InfoMaster server for collection system activity tracking? Now that we have a plan for every line. What you see here is just a shot we took. This shows you guys engaging in the initial beta testing we did for the scraps model and then later on CapPlan. And our guys had to be satisfied. They had to buy into this. Without that, we would not be successful. And I'm very happy to say that there is full commitment to the programs right now. And they are the ones, actually, my vision was to be able to get to the point where we know everything, we know something to do with every pipe, as well as a full 5 to 10 year going out, what is the cost for me for replacement, so I can program my budgets accordingly. It has gone way beyond with the engagement of so many people bringing their talents into the program. So let's look at manhole inspection. This is where the CMOM comes in. So we start, what you are looking at is this is our fiscal year starting October 1 and goes to the end of the September 30th of the next fiscal year. This is a manhole inspection program. What you see here is the good job of interns we hire during summertime. These are guys in the engineering schools. We bring them in here and we run them through. Right now, since we are doing this work, they are out there doing inspection on manholes with our experienced staff. And you can see our goal was 800. They already went past it. Look at the clean out install. We had a goal of 400. This line, what you see here is how they track. We look at this in every weekly meeting and bi-weekly meetings. Our collection system manager and the other managers in the collection department share that with the staff that is in the field. They get to see the same graph there. So if they see they are below, that's bad. If they're above, that's good. And human mind is pretty amazing. You give them a number, and nobody wants to fail. They are always going to make sure that they are above, and they are not going to be failing this. Let's look at the point repair. You can see this is our goal for 100, 120. We are way above that already in this one. Look at the degreasing performance. Same thing here. Look at the basin cleaning. We goal of 175,000 feet. They beat that already. This is the 1 year, 5 year, and 10 year, and they all beat the goals. I'm going to turn this over to Tyler to show how there's a loop here between Cityworks to InfoMaster to Cityworks and then back to InfoMaster.
All right, so we've walked you through a lot. We've shown you how we put our data into Cityworks and how we keep that huge data set going. Once it's into Cityworks, we've shown you how we push that into InfoMaster and how InfoMaster does its analysis. And it's very important to us that we don't stop here, that from InfoMaster we push it right back to Cityworks. So the map here is a subset of some InfoMaster recommended work that we pushed into work orders as a batch. And once you push those work orders in, they're waiting for field staff to come and pick them up and complete the work. We like to call this chasing dots when we put it on a Cityworks event layer like this, that they follow one dot to the next until all the work's completed. And then, of course, since we're putting that data into Cityworks, once they do that work order, that data goes back into InfoMaster once again, and it really keeps that cycle going, and it makes sure our maintenance program is just improving and improving.
Thanks, Tyler. So we went through the whole asset management program pretty quickly. I want to show you the Denton success. You saw that in the CMOM program, all the activity tracking, so that is a great success. Let's look at the financial side of it too. When we started out, we were looking at a 50-year depreciation model. We had taken this to our board and council, and this, what you see here is only up to 10-inch lines, because larger lines are capacity, they're part of the model, and we spend money on those. They're separate from these smaller lines, as well as the plant expenditures are separate. So we looked at total footage, replacement costs, and a 50-year life expectancy, so a 2% each year expenditure. We came in at $4.3 million roughly at an average annual replacement cost for the system. And we sold our board that we don't want to put that on the credit card of the bond sales. We want to do it through revenue dollars because our current ratepayers should be paying for the current rehab projects. And believe me, this along with what we had to do on our bond side to show meeting the bond covenants, was putting a lot of pressure on the rates. In the meantime, we had this going on, the InfoMaster. And when we ran the InfoMaster and we had bidder tested, our guys were satisfied, everybody had bought into that. Then we looked at it and said, okay, now let's look at what the number coming from InfoMaster. And we came out with a total expenditure of $22 million over a 10-year window. Immediately, it showed a saving of $2.1 million compared to this number right here that you just saw. So we took away $2.1 million off the table right off the bat. What did that do? It allowed us now to fund all of the replacement 100% with revenue dollars. We are successful. Let's look at some other things. The main chokes, 359 back, and this is the call that you get from the irate ratepayer, homeowner, business. Hey guys, we can't flush, or the sewer is backing up in my house. That's the number of calls we had. This year so far, 13. This has been great coming down here since we implemented all these things here. Look at the overflow volume, 46 million gallons in 2001, 12,700 gallons so far this year. We had a huge rainfall event in April, back-to-back, really wet conditions, and it's the same Pecan Creek Interceptor line. We got the big overflow there, and that is under construction right now. And overflow number of overflows, 7 so far for the year, 62 compared to back in 2001 as our base year. And with that, you look at, if you have all this in place, I hope that EPA will not come after you and your program will be approved. I'm going to turn this over to Raj.
All right. Thanks so much, PS. Great job. Let me just grab the controls once more. Yeah, so the pre and post strategy is just amazing. So thanks so much, Tyler and PS, for presenting this. Okay, before we get into the question and answer section, we are going to talk about just a few next steps. There is just a very short survey that will pop up at the end of this webinar. It's not the WebEx survey, but it's just the one specific to this webinar. It only will take a minute or so. If you don't mind just filling that out, that'll help us out. Thank you. And then if you're interested in a little bit more information on either the technology side for Innovise, InfoMaster, or InfoWorks, or on the Cityworks side, please feel free to click on one of these links. We will send all of these handouts to you in a file after the webinar, so you'll have access to these slides as well. So you can click on these links and get direct contact with either Innovise or Cityworks personnel. And then you can learn more on your own if you like to get some more information on InfoMaster or the Cityworks suite by those following links. Again, we will post these slides so you'll have access to just click on these links. Okay. With that, I'm going to go to the next section, the last, kind of wrap this up with the question and answer section here. One moment. All right. So I'm going to pull up some great questions came in, so I'm going to pull up some questions, and let's take a look. Okay. So this is for PS and Tyler from the City of Denton. This one's directed to you. There's a couple questions of this variation, but it's basically what, for a utility that's getting started or implementing an asset management system or approach, what would be your recommendation?
Yeah, this PS here, I had to look back when we started the process. At that time, we didn't have the tools that we have right now. Believe me, it's a huge difference from where we were back in 2008 to where we are right now with the tools that are available. So I would say jump in with both feet. You'll have data gaps, but data gaps will take care of themselves if you implement the program, because you will learn what the data gaps are, because right now you would not know that. As you start to fill in all the databases, you start to see where those gaps are, and then you can go out in the field and start attacking that and bringing all that data into your digital database.
That's great. Thank you. Yeah, no, perfect answer. I think that there's a lot of questions on kind of similar to getting started and kind of what you mentioned, just jumping in with both feet, is with data gaps and kind of database integrity. Is there any processes that City of Denton put in place or implemented to kind of rectify any data gaps or any data anomalies when you're using that for asset management or for the asset modeling and planning?
Yes, this is PS here again. Of course, our guys are out in the field. They see any anomaly from what is in the GIS. They will bring it back to the office. And we have, a engineering tech manager who's a real bulldog, his job is to make sure that what the field staff brings in gets into the system once it is verified. And he goes through a very detailed verification process. And it goes through also our wastewater and water utility coordinators. So they look at that data. So Gary, if you are listening, he will take all the data that comes in. He will double check that using as-built, dye testing, in-house pole camera, quick cam, and mainline CCTV. They send out people to check it out. Once verified, at least twice, corrections are sent into the GIS tech, and then they copy that to our coordinator. And it is entered into GIS. Then Gary will send out an email that the GIS changes have been corrected. Our coordinator then, over time, checks it, verifies that it did go into GIS, and all those are correct or not. So we do have a process in place. Thank you, Gary, and Haley, and Tyler.
That's great. This one is kind of maybe digging a little deep, so feel free to answer. You can also answer offline. But a question came in about the parameters that were used to estimate the global risk associated with pipes, apart from material diameter and installation date. Any major variables that you guys use?
Yeah, I'll give you an example. Like how old are the pipes? It would have been a humongous task to go in and dig in through all of the as-builts, and who knows how good all those as-builts were from the 40s and 50s and 60s and so on. So we looked at, our general government maintains a layer for subdivisions when they were platted. That is very correct. So we said, okay, if we don't know when this line was actually constructed, we will tie to when the subdivision was platted. So if the line got constructed within a 5 to 10 year window, and if it was the old line, that was good enough information to go forward. And we then went in and that's how we got the age of the pipe. That's one thing we estimated. We made assumptions on the type of pipe. We said anything over 84, beyond 84 was PVC, and prior to that was all clay tile. So we made lots of assumptions at that time. We didn't know everything, and we couldn't really go out to the field and really pull all that data at that time. Hopefully that gives you an idea of what to start out with.
Great. All right. We'll do a couple more questions, quicker questions, I guess. One is, what percentage of the Denton system has been CCTV'd?
Well, we initially started out, CCTV was the one that drove me to it to begin with, because that's a very expensive, time-consuming thing to do, and we went to priority ranking and then started doing CCTV based on the priority ranking. A paradigm change has happened with the quick cam. We got a camera now that's sturdy. We can use it in 6-inch lines and larger lines now. So every time, in the 5 and 10 year as you saw, the flushing cycle. Those trucks are now equipped with our quick cams. So all the lines that are flushed as part of the program, they also get a quick cam. So we can see what is wrong with the pipe. So this has really escalated in terms of the CCTV information. And we anticipate that in a, the less than 10 years, we'll have a CCTV inspection of the entire system.
Wow. All right, great. We're going to do, there's a lot of questions that came in just regarding this webinar, if it's going to be recorded and sent out. The answer to that is yes, we have recorded this webinar, and we'll take a day or two to process, so probably early next week you'll receive an email with the link to view this webinar if you wanted to send to colleagues that missed it, or if you wanted a repeat showing to look at any finer points. But with that, it's on the hour, so we're going to close out. We want to thank all of you for attending. This is our contact information. Again, we will send this after the fact as handouts. But thanks so much, PS, Tyler, and Brent for joining us. It was a really great presentation all around. And with that, everyone, have a great day. Thanks again for joining us.